Lovely.
Perfect. Yeah, you can get started whenever you'd like.
Okay, and just let me know also if I go a bit over time, don't hesitate. I can also add a bit more content if people are interested. Obviously, I can answer questions, but like really feel free to let me know if you read them. I sped on. Well, it's lovely to see you all. I hope you're going to learn quite a bit today. My name is Eleonore, and I'm going to be talking about analog space missions, but mostly about how we teach and prepare for space tomorrow with them. Shortly about myself, if I can change the size. Yes, I can change the size. Fantastic. So I'm a PhD student at the University of Cambridge in the UK in materials and metallurgy. I'm actually handing in a week. So yeah, it's exciting. And I was an analog astronaut and a commander for the student-led and student-made analog space mission Asclepios 1. From this, I actually started CHASM, which is the Community on Human Analog Space Mission, where we create workshops, conferences. I teach a class on analog space mission. I'm operation support team for Astroland, Interplanetary Agency, the Austrian Space Forum. I'm an analog astronaut for FMAS and Habitat Marte online. So it's quite interesting because I've had to touch into a lot of these different worlds. I get to see lots of those different analog space missions. And it is an absolutely huge world. Like we have no idea how big it is until we get into it. So I have a question for you. Like the Earth and Moon is more or less to scale, the distance is not. But one of the biggest differences that we have in missions to the International Space Station, the Moon and Mars is the time and the distance. Right now, if we go to International Space Station, it takes us a few hours or a day or 2-3 days if we want to actually go around and around, but we could get there quite quickly and you can come back quite quickly. And the 60s and 70s, going to the moon took a few days to go. Right now, going to Mars will take 6 months to 8 to 9 months to go there. So the way we have to think about those missions is completely different. Especially if you look in the 50s and 60s, going to space was about doing a technological challenge. It was about getting the right spacecraft, the right engineering to get there. Obviously, you needed the right people, pilots who could really maneuver and stay calm, but you really had a different perspective. It was more like going there, putting a flag and coming back. Now, if we go back to the moon, we've been there before. So there's no interest in going back and just, putting another flag and just saying like it is. And going to Mars is obviously a much longer time commitment. And this is where analog space missions come really into play, but at least the ones that I would name civilian analog space missions. Basically, when you go to Mars, you're going to go there and try to stay for a while. You try to think in terms of settlement. You try to think in terms of habitats, not staying in a tin can. So that changes completely the kind of knowledge that you need and the kind of tests you need to perform on Earth before you go to space. I believe that analog space missions are a really big part of the solution for the preparation to long exploration, like Mars exploration, etc. Why? The left side, you've got a space shuttle. I mean, as incredible as that project was, I said that the space shuttles were absolutely amazing. They were costly and they were dangerous. Space is costly and generous, okay, and dangerous, and you need not generous, dangerous. It's right, it's not the same thing. The problem is you can't do hundreds of iterations. Obviously, we saw yesterday with the SpaceX launch, it was beautiful. It did fail at the end, but it was a good test. But you can't do 100 of these, and you can't do that with people, okay? With analog space missions, what we do is we recreate part of space missions on Earth. And by doing them on Earth, we reduce the danger, we reduce the cost, and we can have a much higher viability of crews, of habitats, of mission duration, and basically investigate all those kind of different aspects that we can't really do with space mission because it costs us too much. Obviously, now we can send people, for a couple of hours, in a capsule, and we can test different backgrounds, but it's still costly. We're getting there, but it's still costly. And you could say, well, from a sustainability point of view, it might be worth it that we do as much as we can on Earth, and then we do a few tests, and then we go. Okay, So this is what analog space missions do. And there's actually a big variety of habitats. I mean, there's over 20 analog missions around on the world, probably even more because it's booming so much that in the last couple of years, at least 7 of them grew, okay? But there's a lot of different ones. And just to name a few, on the left-hand side, you've got, for example, Astroland. Astroland is very interesting. So they're located in Spain and they are in a cave. Basically, the cave is 1.6 kilometers long. Some part of the cave is 50 meters high. And you have to walk about 1 kilometer wearing your spacesuit to get there. What is very interesting with this habitat is that it's located in, a rock formation. When we go into the moon and when we go to Mars, we're not going to be shielded from radiation because there's not really a magnetic field like the Earth has. Magnetic field protects us from solar flares, from radiation. We won't be protected, and that's going to be very problematic. However, there are natural formations called lava tubes, which are resulting from volcanic activities. And we can put our habitats in them, and then we get a natural protection. So instead of getting a massive lead or concrete wall that you have to fly all the way to Mars, well, you can actually just use a natural formation. So there are different analog missions who test that. To test how is it to be in these environments. So for example, high seas in Hawaii, they do sometimes test like being on a volcano and part of those formation. I see space with the Chill Ice mission in Iceland, and what they do is the test. That's really cool. So they tell the astronauts, you have 8-hour autonomy in your spacesuits. You've got your habitat, which is an inflatable habitat, and you have to go, walk, and get into the lava tube. But you have to inflate your habitat, and then you do your mission. So it teaches you resilience. It really simulates the thing that you have a deadline, you have an oxygen limit, and once you're in there, you can really see, is it practical being in a lava tube? Okay, so this is one kind of location of habitat. Then you've got, for example, habitats like MDRS on the right-hand side, but there's the same habitat in the Arctic. So that's more being in a kind of dangerous environment or more extreme environment. So very cold or very warm. And also what's really nice with the right-hand side, it's in Utah. And in Utah, it looks quite reddish, a bit like as if you were on Mars. So you really create this illusion, this simulation that you are on a different planet. This is not, my home country with like grass and, green trees. No, not a tree on the horizon for kilometers. I'm on Mars when I'm in MDRS. And you can also have habitats, for example, Lunaris on the bottom left side, which are in the cities. You don't actually need the habitat to be super far away. It really depends what you want to simulate. You can simulate the isolation. They do extravehicular activities. They have a huge, basically, sun pit, and they do the EVAs there. They put their spacesuits on and they go in there. And lastly, the more extreme kind of habitats is the underwater ones. There's several habitats. One example is the hydronaut habitat in Czech Republic. This is how it looks like when it's on the ground, which is actually the current status. So if you want to visit it and you can't dive, now is the right time to do it. We're actually organizing an event there, so maybe you can join. But for example, these habitat is really good because if you look at the danger level, Lunaris is easy in the sense that you can get out really quickly, and you can walk in there, walk back, and you're in the city. MDRS, you open air, but you're in the more or less the desert. Well, it gets warm, okay? You're quite remote. Astroland, you have to walk at least for 30 minutes from parking, which is an hour drive from the city, and you have to climb down for 1 kilometer in rocks. You have to be fit. And then hydronaut, if you don't know how to scuba dive, you can't get in there. So you can work on different levels of danger, of simulation, that you are in an extreme environment and a friendly environment. Space is the unfriendly environment. It's not fun. It's beautiful to look at. It's nice to float in it. But if you get out without spacesuits, you're dead. Okay. And this is the thing that we can't 100% recreate with analog missions. This and microgravity. But obviously, habitats that are actually underwater help in creating a bit more of the simulation, because there you really are in danger. Like it is primitive. You get help much quicker, but you are in danger. What happens actually during a mission? So these are, sorry for the self pictures, but these are the pictures from my mission. So you do experiment. What you try to do during those missions is you try to become an astronaut. Okay, so you follow basically a schedule like an astronaut would do on the International Space Station on a mission. You've got a flight plan. You wake up 6:30 in the morning or 7 if you're lucky, and then you do your experiments. You eat. You do your sports. Why do you do sports and other missions? Well, for one thing, it's good to have endorphins. It's good to be fit, but also you do want to simulate the fact that in space, International Space Station, typically, they have to train about 2 hours every day. If you don't train, when you come back to Earth, you're in deep, deep, deep trouble. And even if on Mars you have reduced gravity, the trip there, you are going to have to train. And you still need to train a bit there, probably reduced, but still. So for me, those sessions were great because I love sports. It was a way to get some me time. But these are part of your daily work, is that you do experiments the whole day. And even things like eating or doing sports, you actually sometimes have to send a report to the Mission Control Center. It's assessed. And in a way, it's nice. I mean, normally when I cook for myself at home, I don't get a star, hey, you did your work well. I mean, my bladder might say something, but that's it. With an analog mission, it's important. It's data. It's understanding the well-being of astronauts. There's so many criteria that actually impact the well-being of astronauts. And it can be how much sports they did, what was the food like, what was the workload like. And again, it's really interesting because it can be a huge variety of contexts and flight plans doing analog missions. Some interesting parts also that you might not think in analog missions is all the logistics and, for example, life support systems that go into them. Obviously, space, there's the whole human factor, but there's also the whole preparation. And even for an analog mission, if you're going super far away or you want to really simulate the fact that you can't go home like this, you have to plan everything. So on the left side, you can see some of the food that we had. Every item was labeled. Every item was in a database. Everything has to be referenced, and you need to know why, because you need to prepare for it. You need to say, okay, do we have enough food? This item is missing. How do we cope with it? Oh, we can replace with this one. We know this one is in the inventory. Yada, yada, yada. Okay. In space, it's even worse. So actually preparing on Earth with this in mind, that you're going to space and nobody can bring you a screwdriver in space, is really good, because it really puts you in that context. We had several problems actually doing our mission. We were missing some magnets from some of the experiments. We had 2 fuses blowing up, and actually we only had one left, and it was at the beginning of the mission. And actually really, really impacted the mission, because the base was at 13 degrees Celsius, 90% humidity, which means you freeze, like you get really cold. And we had heaters and dehumidifiers, but these were actually too power hungry for the electric grid that we had in the base, which meant that we just decided, okay, well, the only place that actually needs to be heated up is the experiment room and a little bit outdoor, and the rest we don't heat up, and we just shoot up and try not to get too cold. And funnily enough, this impacted the food, because suddenly we were using much more calories. We were actually much more hungry because we spent the whole day having to heat up ourselves. So luckily we had some backup food, we had enough, but if we had been in a much longer mission, having not taken those difference in temperature could have been critical. So this is something that we already learned, okay? And on the right-hand side picture, you can see this was the gym. So these are the promotional pictures. That's why he's wearing a spacesuit, but we don't wear a spacesuit in the base. That's only when you get out. It's just because it looks really cool. But you see like kind of the gymnastics, and behind you can see the sanitation. And again, those logistics, for example, we had this dry toothpaste and it was absolutely awful, or dry shampoo. I mean, it looked like, I don't know, I hadn't washed my my hair in 6 months instead of 8 days when I tried to wash with it. And it's again stuff that you need to test. It sounds dumb, but you need to test for everything, especially if you're going away for 1-2 years, okay? I have a question for you is, what do you believe is the difference between astronauts that go to the moon, astronauts that would go to Mars, and astronauts for the ISS? Don't know if anyone wants to answer in the chat shortly. And if you're too shy, don't worry. Okay, maybe you wanted to say something?
I was going to say, I can try kicking off the conversation. So like my initial intuition as someone who's really into space medicine would be, the preparation for these astronauts, because obviously there are different distances. And when you're in the ISS versus Mars, there's a lot of different like a lot of difference in exposure of what your bodies will be exposed to and what you need to be prepared for. Like for Mars, like there's a lot more radiation. So astronauts need to be prepared to figure out what are countermeasures to radiation, what can we do? Also, going to Mars is a lot further distance for a longer period of time compared to the ISS. So they need to physically and mentally be more prepared than an ISS astronaut. And also when Mars, the communication back down to Earth will take an hour. And so you need to be prepared for medical emergencies a lot more faster and quicker. You need to have that technology with you compared to an ISS astronaut. So I think the distance creates health and other technological differences between these astronauts.
That's very true. But funny enough, it wasn't the point I wanted to make, because it's even more differences. And that's something that actually Sarah was mentioning before. It's diversity and what we're going to do on Mars. So we have to take into account the whole health, and this is something that's more difficult to do with analog missions because we don't have the microgravity aspects. Although we do, I think the Australian Space Forum right now is selecting some experiments, for example, to see the effects on the genome of doing those analog space missions. I don't know how much it's going to have an impact. I don't know if it's going to be measurable, but we can already try to see the measurement. The big difference that we're going to have with going to Mars, for example, is we're going to probably strive to create a civilization. If we go to Mars, it's potentially to become a multiplanetary species. And how do you differentiate sending astronauts to the moon and planting a flag to creating a civilization? Is it when you start sending people who I would say are useless in an engineering standpoint? Nobody is useless. Everybody's part of civilization. But obviously, you need first somebody who can repair for example, the spacecraft. But at some point, you send people who don't need to be repairing this, but actually make civilization, and not just survival. And this is where analog missions are very interesting. On the left side, you can see, well, it's not, full spacesuit summation, but it was an analog astronaut doing the Habitat Mater mission in Mars, playing the violin, for example. And I think this is an example of, striving to have a broader pool of analog astronauts, finding more people, finding people from every country and every background, because as you said, Mars is very far. What's going to happen to us when we are on a spacecraft for 6-8 months one way, 2 months, 3 months on site, and then 6 months, 8 months back? Probably our religion or our country is not going to matter that much anymore, because the only people we're going to have in direct contact are the people who are with us in the spacecraft. So we're going to be maybe a new kind of nation, and we need to understand this. We need to work with this diversity of crew, because if we want to create humanity, we need to bring everyone with us. And that, I think, is a wonderful aspect of analog missions. And we can do different things. You can do 100% female crew, 100% male crew. There's, like, for example, Spanish or Portuguese speaking only missions, or Chinese speaking only missions. So you kind of really do lots of different parameters with this analog space mission and test that. And I think it's very, very interesting to see the results and how we learn from each other. And from an education standpoint or experiment standpoint, what I find very, very interesting is that you not only develop skills like team psychology and leadership. I'll send you guys, I'll put at the end a slide with all the different skills you develop in our mission. But one aspect that you have that is very, very important in our missions is the experiments that you perform. And it's rare that you would be, for example, a chemist and do 100% chemical experiments, okay? Like, it's not going to be just chemistry, or it's not just going to be biology, or it's not going to be just this. So you're going to get training for something that is outside of your field. And a biologist does not behave the same as a chemist, who does not behave the same as, I don't know, an engineer. We're all very different. We all have different trainings. We all have different automatism. So it's very interesting, because you get to see much broader aspects of experiments and of different sciences, or just soft sciences as we call them, and you can test different parameters. Psychology is absolutely huge and it's very important in analog missions. Typically just the isolation, the crew dynamics, and then you can put architecture linked with psychology. For example, if I paint my habitat pink, is that going to impact the crew, or is that going to be fine? I mean, are we going to all want to eat donuts, or is it just totally okay? You know, other people might be more affected or less affected. We're all very different. Then there's the whole agriculture, so what we call hydroponic or aeroponics that we do in our missions, robots, drones, space maintenance, the whole engineering. Well, a biologist might learn how to repair a drone, for example, because we need to be redundant. So from a teaching point of view, I think it's absolutely incredible. I've been doing my PhD for 3 years and a half, and I think I learned more doing my analog missions and all the work I did in that I actually did doing my PhD. Doing my PhD, I learned something that was very much in depth, but that I might not use as much data. I learned how to work, that was fine. But in analog space mission, I learned how to do way, way more lateral work, because I had to do this at OSD, because you have to be this kind of Swiss knife and do a bit of everything. And what's also very interesting for students, for example, is that you can send some research to be performed by analog astronauts, or you can be an analog astronaut, perform the research, and then you can publish it in astronautical journals. And that's also very interesting if you want to show that you're doing something serious, that you can get some teachings in academic writing, and it's a kind of platform to get into it. One thing that I absolutely love that I'm getting into right now is parastronauts, and it's not only teaching to get everyone in, inclusivity, it's actually touching off a very, very important topics. When we go to Mars, it's quite likely that we're going to come back completely effed, if I can say. I did say it before. Obviously, the consequences to the body are absolutely huge, okay? And the likelihood that you're going to get an injury, for example, you might cut your finger, or maybe you're going to break a bone, or usually your eyesight goes down when you're in space. Okay, and if you're going to be there for not just 6 months, but actually 6-8 months there, then a few months on site, and then 6 months back, then the duration is absolutely huge. So it's better to learn now how to deal with people with a form of disability, like being blind, missing an arm, not having any legs, than learning once they're over there. And as you mentioned, communications to Mars, one way is between 4 to 20 minutes or such, back 4 to 20 minutes, and you take, I don't know, maybe 5 to 10 minutes to think about the message you're going to say. Okay, so it's very, very important that you've got everything planned. And this is something that's being done with Lunaris. So Lunaris in 2017 had the Icarus 1 mission, where they had an analog astronaut who lost both his eyes and one arm. And they just adapted the habitat for it, and it works perfectly well. And right now they just made calls for the Icarus 2 missions. So it's 3 new analog space missions with astronauts with disabilities. And we're trying to basically look into, how do you adapt the habitat? How do you adapt communication for this? I don't know if you ever had this when you have a cold and your voice is really stuck and you wish you could speak sign language, because it means you wouldn't have to use your throat. I have that every time. And every time I'm like, I can only say the alphabet, I can't speak. And I find it very, very annoying. Or, you know, sometimes your eyes are really tired and you don't want to turn off the light. You just go like this. If we already develop the skills, if we already develop the coping mechanism, we can already think, okay, how are we going to solve things? The other thing that is interesting is people who, for example, don't have legs are less affected by microgravity, okay? They don't have the same gradients in differences in pressure, blood pressure, and therefore they don't seem to be losing as much, well, they shouldn't lose as much blood and as much bone mass. And that's very interesting. And lastly, I think what's very important is people with disabilities are used to an extremely unfriendly environment. The world as it is not a friendly environment for people with disabilities. It's not made for them, which means that every day they're used to being absolutely extreme environments. So what's best for them than space? In space, suddenly your legs do not count if you're disabled. In space, if you're missing an arm, it doesn't count anymore. You can move around, but just, you know, you hook yourself up and you just pull and then you go like this. It's fantastic. it's a wonderful opportunity. And who is better made for this than actually people with disabilities? I mean, for able people, probably you'd be like, I miss running with this thing and I miss, I don't know. And for somebody else, it's suddenly that burden is probably lifted off. So I think there's absolutely a lot to learn with these missions. Obviously, again, you don't have the microgravity aspect of things, but we can already do a lot because there's barely anything. I mean, ESA has opened last year to astronauts that have a lower limb disability, but that's a very limited disability. There's actually much more to see. So yeah, this is basically what do we learn in our missions and what does it teach us basically? Scientific skills from psychology tests, medical tests, chemistry, engineering, whichever you need. Soft skills, like you have to live with a team. You have to be, if you're an analog astronaut, your crew is going to be your roommate, your best friend, your commander, your employee, and also the person you trust with potentially your life or part of it. Okay, so the communication you need for this is extremely high, and you need also to be very efficient in your communication with Mission Control Center. Inclusivity also, as I mentioned before, and obviously everything about space exploration. All the whole logistics, all the understanding of going there, of becoming, trying to strive for something greater than us. I think really those missions are absolutely crucial to get us to space. And very, very useful platforms. And if I were to, so I'm going to just pass quickly, these are my contact details and I come back to it. But these are some of the skills that I personally had to learn doing my analog missions, and they've been absolutely amazing. And I'm actually currently trying to get the University of Cambridge to collaborate with analog missions to get students to do this instead of an internship, because sometimes an internship might be not long enough or provide you only a certain set of skills. Whereas if you do an analog mission, you can really do these things. And some of them, sadly, you have to pay for, and you don't necessarily have the money. So if you can get them as a kind of paid internship by university, then you get a fantastic experience. And I mean, who knows? Like, for example, I did survival training during one of the missions, and I got really hooked. And now I'm going to try to do some expeditions to the Arctic and Antarctica because I think it's fantastic. And my platform, my jump off was this. I never learned how to talk to media before. And I had somebody to talk to 15 cameras and get on the news and things like this. And you have to learn these things. And once you've learned how to do them, you know, it's not a big deal. Okay, yeah, okay, one more skills, I'm going to be fine, you know. I think 2 years ago, speaking in front of you, I might have stressed before. Whereas today, I could just enjoy the panel before and be like, okay, I checked everything's fine. These are fantastic skills. And the more you have of them, the easier your life gets, because then you can choose to go wherever you want. So for students, I think really those missions are crucial. If you have any questions, you want to follow CHASM, which is the Community on Human Analog Space Mission, we have events every 6 months. We have an Instagram and a Twitter where we basically share news and information about our missions, some opportunities that exist, what kind of things we do. We're creating a wiki with all the different analog space mission, how they made, etc. We're going to release it in September. And if you want to contact me privately also, you can do so. On LinkedIn, my name is Eleonore Poli. And yeah, it's been lovely. I hope I didn't go too much over time. I think about 5 minutes. Sorry about that.
Yeah, we have another 30 minutes of conversation where we could do a Q&A. So yes, no worries. That was an incredible presentation. I know I learned so much. Here, we can stop sharing so we could do more of a Q&A now. But that was such an incredible presentation. I'm not sure about the others, but I learned so much. Analog missions have always intrigued me as someone who's aspiring to become an astronaut. It's the perfect next step, especially for young students. So I have so many questions, but I'm sure everyone who's listening does as well. So feel free to turn on your mic and video and ask your questions. But to kick off the conversation, I wanted to start off by asking, how did you get into your first analog mission? I know as a young student, there are so many opportunities, but they're all oh, you need a degree or you need to have certain skill sets. It's not just enthusiasm or excitement. There's a lot of requirements. So how did you navigate finding your first analog mission that enabled you to get all of these really cool experiences?
I think I got catfished is probably the answer. Basically, it was almost 3.5 years ago. I follow every kind of space stuff, and I was on Facebook, and the Swiss Space Center, which is now Space Innovation at EPF in Lausanne, where I studied my undergrad, said, do you want to be an astronaut? I was like, yeah, of course, because you have to understand that in Europe, for us, the only opportunity to become astronauts is via the European Space Agency. We can't go via NASA. And ESA recruits every 15 years, and it used to recruit only 6 people, right? Now, this year they did 23 people, more or less. But like the opportunities are for us quite low. So for me, seeing this, and it wasn't ESA call, suddenly I was like, wow. And actually, I realized it was actually Analogue astronaut, right? But the recruitment was actually really great because they based it on doing recruitment like ESA. So we had CV, motivation letter, we had cognitive tests, we had psychological tests, psychiatric evaluation, an interview with astronaut Claude Nicollier, group tests. Like really, we had the whole package, and we had to pass a short medical test. So it's not as intense as ESA, but it was quite high. And we were supposed to have the mission in 2020. And of course, COVID hit. Fantastic. So we all become Analogue astronauts for about 6 months, didn't we? By being stuck in our houses. And I was listening to a lot of different talks, and I learned about other Analogue missions. I had heard about, for example, Mars 500, which was an Analogue mission that took place in 2012. It was about 512 days long in Russia. It was a joint experiment. And I've had heard of other stuff, but actually for civilians, not really. And Asclepios was one of the first I heard of. And I met with other people from, for example, Chile, IC Space. I think Susan is probably here. Yes, so I met Emma Mars also. So different missions. And then suddenly I was like, wow, there's a whole community of this, but actually we're not linked. And this is how I founded CHASM. I founded the Community on Human Analogue Space Mission because I was like, what we do is so incredible. It's such an incredible community. And as you say, you know, I wanted to be an astronaut, and I thought doing an Analogue mission was a great way to test this. Am I going to kill the people with me? Am I going to actually stand them? You know, I don't know how I'm going to react. I know how I react in ski camp. I know how I react 2 weeks with my family, but I don't know how being stuck in a tin can and doing work 15 hours a day acts on my psyche, right? So what I love about this community, and I see it for every event I organize or every talk we have, is we all kind of the same people who wants to sacrifice their weekend, because most of us are volunteers, and we want to sacrifice our weekends, our free time to actually better science and understand better what's going around us, and also test how to be astronauts. If you tell someone randomly, I want to be an astronaut, they look at you like, yeah, grow up, right? But in the Analogue astronaut community, it's normal. You are surrounded by people who actually want to. Some of them know that they can't because maybe they have a heart problem or something like that. But a lot, it's actually a dream, and you get to live that dream partly, and you get to share it with people. And finding that community is really a relief. So every time I meet students who have actually lost into getting into the space career, I try to tell them, well, try to join this, because you're going to be with like-minded people. And even if you don't want to be an astronaut, you will maybe be working in the mission control center. Maybe you'd be an engineer working on spacecraft. So you might want to actually get into that. So you can say, oh, I want to create the rover that we're going to test in the Arctic, or we're going to test in Egypt, or wherever the mission is going to be. And as Sarah actually was an Analogue astronaut before she became an astronaut. Sian Proctor too. So you can see that obviously it's not the majority, because the requirements are usually quite different. They're not as high level, but still it is becoming more and more kind of a stepping stone for it. And I think it's really exciting, really, really exciting.
Yeah. I think Ben has a question.
Hello, my name is Ben Stanley. Apologize for the dog. She really
It's so cool.
On a walk. So she's bugging me. But I'm just finishing up my master's degree at Stevens Institute of Technology in space systems engineering, and I'm actually doing my thesis on analogs. And one of the things that I think is really interesting, you know, based on the discussion that we previously had about the different types of astronauts that we're going to have for like a Mars mission or a moon mission or whatever. I feel like there's this gap right now between what our stated aspirations are, where if you're SpaceX, it's colonize Mars. If you're Blue Origin, it's millions of people living and working in space. If you're NASA, it's going back to the moon, this time to stay, right? This like new like settlement, long-term development paradigm. And I feel like when I have looked at analog operations, it still seems to be very much in this older paradigm of the temporary 1 to 2 week tops mission, where we still go and do valuable stuff and learn valuable things. But I'm just really curious on your view of what I think is this big disconnect between what we're doing in analog operations, which seems to be much more the old paradigm of how we did the Apollo program, and what we're stating we currently want to do, but are apparently not really focusing on the way to do that within analogs.
So I think the biggest gap that you actually have right now is more the knowledge that we have about the human body. At the moment, the longest real space mission you have was, I think, 437 days. Whereas if you go to Mars, it might get longer than this. So for me, that's more the part that concerns me. It's not something we can bridge with analog mission. For analog missions, you're right. If you look at civilian, so non-agency made like space mission, they're usually very short, as you said, about a week, 2 weeks, sometimes 48 hours, sometimes only 4 or 5 weeks, even for the more realistic ones like the Australian Space Forum. The reason for that is because we volunteers. If you look at NASA ESA mission, for example, NASA just made a call for its, how's it called? Is it CASA? I think it's like 1 year, something like that. So obviously agencies that can, for example, pay you for this or you know, do things, they can ask you to be there for like a year. But when you volunteer and you already pay for that mission and you take time out, like for example, I am supposed to go to Earth Mars for a month and I have to pay for it. I have to take time off work. I'm going to be tired after that mission. Is probably going to impact the quality of my work. So that's the problem, is you have to think all those missions are almost on a voluntary basis. So you can't ask people to be away for a year, you know. And also, if I were to ask you now, you get to be a year away from your work, from your family, from your dog, for example, but you don't get to be on Mars. You don't get to see the Earth from so far away. You don't get to be in microgravity. Well, you don't get as damaged also, but would you do it?
Yeah, it's a tough sell, right?
See? You could, but it's not the majority of people, because one of the appeals that we have, one of the offsets is like, I'm okay with my body getting really damaged, but because I get to be in space. If I'm doing an analog mission and actually have the choice of doing 20 different missions that are 2 weeks, that already teach you so much. To give you an idea, for Asclepios, we did a 48-hour rehearsal before. So the mission was only 9 days, and 9 days we were 450 meters on the ground. It was really, really good. And for the rehearsal, we were in a bunker for 48 hours, and we really did the flight plan. We had all the food, also with the labels. And it was, for example, MCC to base, take item KI 17 with KI 20 and blah, blah. And we had a joke because we were supposed to, we had plants, we were supposed to have a robot that would monitor the plants. And we're supposed to take basically our human waste, okay, so fecal matter, take it and just nurture the plants. And we called it composting. And every time we needed to go to the toilet, we had to do an EVA for composting. Okay, that was our little joke. It's like MCC to base requesting EVA for composting. Okay, so we did that 48 hours. On the last evening, so we finished a Sunday evening, I had a flight back to Cambridge and I just sprinted to the airport. Then the airport was waiting and I was on the phone. And I remember requesting EVA for composting. In 48 hours, my brain had already completely changed the mechanism. The next day, the next morning, so I've been out of the base for over 16 hours, I was trying to eat hummus and I was looking on my hummus where the number was. I was waiting for the KI 36 so I could remove it from my inventory. So it shows that even a short stay, even a short mission already rewires your brain, already changes automatism, can already show you the shortcomings that your mission might have. And that's what I think is very interesting, is that we don't realize how much there's to do in a space mission until you do an analog mission. Even with a low fidelity, there's so many things to see. It's okay to do that. The only times where you really need the duration effect is psychology, and then from a physiological standpoint. And this is what, for example, Mars 500 was doing. This is what NASA is doing right now. But yeah, I hope that answers your question. Hopefully.
Yeah, I mean, I feel
this is Susan here. I'd like to answer that question too, if I can. Hi everyone.
Sure.
Hi, I'm Dr. Jewel. If I do get a chance to present a few slides of what we're doing under MMOS, and thank you for mentioning my organization there, Eleanor. Hi. So Ben, to answer your question, everything that Eleanor stated is true. However, the next evolution of analog astronaut training, and we've been in this field since 2014, so we're one of the early, sort of, you could say, vanguards next to the Master Society, the MDRS. So we actually know what the challenges are and everything. And the model of the short duration for analog is it's actually just what Eleanor, the challenges are. And usually it's financial. But however, the next evolution of these training analog missions is going to be longer duration. So for example, the Johnson Space Center there, they're not the hero. They just built the 3D printed analog station, or their base camp inside a warehouse. As always, they keep it all internal, nothing external. But it's going to, and they've already selected their crews. So this is under NASA, and they're going to stay there for a year. So the expansion of duration of mission is happening. And then if I get a chance to present a few of the work where we're expanding analog missions and the different caveats that we set up over the years, going to all high fidelities, more austere, dangerous environments, focusing also not only on human studies, but also on technology, space medicine, med tech, all, and food and diet and innovation, which is what these analog missions are also encompassing, right? Not just the human studies, the psychological is a very important issue. I think that's one of the major limiting factors for us to actually succeed to live long-term in space. If we cannot find mitigating countermeasures for the human aspect, then that's going to be an obstacle. However, I do emphasize, because my background is in medicine and space medicine in particular, is to date, we cannot do surgery in life-threatening situations, in dangerous environments. That's why we do analogs in these high fidelity, like Everest Space Camp, going to Arctic, going, underwater, is the fact that there will be high risk of life-threatening emergencies. So what can we do? And when you think on average that most NASA astronauts have less than 6 months of medical basic training, in other words, they have less training than an EMR, right, an emergency medical responder, and then you throw them up there, yes, they have mission control, they have flight surgeons, but still, on when they're so remote and there's a life-threatening situation, to date, they cannot do any real medical intervention per se, surgery or anything. So we've been tackling that issue. So when we're talking about permanence in space, we definitely need to have these analogs where, one, you're going to try to develop the technologies in these environments. And I would say the reason why we go to all these different environments, whether we go to Everest high altitude or the desert when it's extremely hot, is that not only human studies, but the technology, use of feedback, data you want to collect, but also the technology itself. So for example, in the desert, we had a 3D printed, was $50,000, robotic arm. It melted in the desert here in California because it went up to 115, 20 degrees and it started melting. And oh my God, And then when we went to Everest, we had a solar powered 3D printer that we created. It didn't work because we went to monsoon season, there was hardly any sun. So these are where it's going to go. So for us, and
Suzanne, Suzanne,
go
could
ahead.
you share the links to MMRs and the different projects you have? Because I think it would be very interesting for people to see those different outcomes that you had. Very interesting that a robot arm actually melted.
Yeah,
Pretty hardcore.
But I think if I have a few minutes, I can show you some slides of what we have done, where we're going. We're actually building the first analog space settlement in the Mojave Desert
I
with
would love
sponsorship,
first for
obviously,
Martina to
you
ask
know.
her question, and then I don't know, Gitika, how it works with the schedule. I'm just the speaker, I'm not the moderator. So Gitika, you let me know. But I don't know, Martina, if you had maybe a question, and then maybe we could search. You let me know.
Yeah,
I
sure.
think I was going to say, yes, let's start off with Martina's question.
Yeah, thank you. My question has two parts. First part is what would be your suggestions for somebody who would like to try their first analog mission? And the second question is, how did you choose which mission to go to? And did you really see a difference between, let's say, doing moon mission on Earth versus Mars mission versus any other mission?
So the first question, it really depends on your time, your objective, your amount of money that you have, and some of the abilities. For example, if you cannot move easily, for example, astronaut is not very accessible. If you have not too much money, then you might want to apply to some missions where they're sponsorized, and like, for example, if you're a researcher, then you might get your state to be sponsored and you can reduce the cost. Also, you have to think, some of them are in Hawaii, some are in the United States, some in Brazil, lots in Europe, in Poland, in Iceland, Spain. So where are you, and where are you okay to go to? For example, for me, I would love to go to high seas, but it's in Hawaii. And from a sustainability standpoint, I don't really feel okay going to Hawaii for this. So if I go there, probably I'd do a month holiday and 2 weeks mission, so I don't go back and forth. So there's a lot to take into account. This is what we're trying to do with CHASM. We're trying to really map out the different missions, and then you make the decision. I can't tell you, because I don't know your situation. And even so, sometimes it's also a feeling like, do you want to go with a specific crew? Some missions do very specific oriented crew, like all female crew or Spanish speaking, or for example, if you want to take part in the CARIS 2 missions where you can test with astronauts with disabilities, then it's very interesting. Hi Thomas, speaking of this. So it depends what you want to do, and also where your research wants to be focused. A lot of those missions, you come with your own research. So you have to think, if a mission has more hydroponics and aeroponics and you into that, then it's great. But some missions do not have them, and you can try to bring them. You have to be aware that some of the facilities are limited. So the best is really just have a look around, see what are the opportunities, how much it costs, and then you make the decision. For me, really, Asclepios was a no-brainer, because it looked amazing. It was in Switzerland. I'm Swiss. It was organized partly at EPFL, which is where I studied, which is a really good institute. When I did the recruitment, it was very serious. So for me, it was a no-brainer, because it was the beginning. And now when I pick a mission, I basically look to what brings it to me. Like, for example, the mission I want to do to Earth Mars, it's in the Arctic. So for me, it brings the side of extreme environment, exploration, being far away. I've never been to the Arctic, and there's the whole part of rehabilitating the base. For Lunaris, the Icarus mission, for example, I would probably not do a normal mission at Lunaris. I want to do the ones with the disabilities mission, or hyperabilities as we talk them. Why? Because I'm interested into that. It's something I want to contribute to. But I know that, for example, this year I don't have enough holidays to do it. So it's like you really adapt depending on just where you want to be, how much time it takes, what is your focus. So yeah, I'm sorry, it's a very broad answer, but it's the one I have.
It's really cool. And this is really tricky, because as you are speaking, I keep thinking about additional questions, but I'm not sure if we have like space to ask them. I'll leave it up to you guys.
If you need, you can also just send me an email or contact me on LinkedIn and follow our CHASM, and you can send me basically what you think you want to do, and then I can maybe guide you a little bit. But I don't know if you have maybe another general question, or anybody else. And then Gitika, I don't know if you want to also leave space for Susan, I don't know.
My question was about funding. How do people usually fund it? And is it like a problem to fund it? And also like the partnerships and research, how do these work? How is it the participants bringing on their own research, or is it somebody else helping you? Because this is something that I've been trying to also do when I'm in healthcare innovations. Sometimes I come across innovations that would be fantastic for analogs, but these companies on Earth are not always like aware yet of space medicine, right? So this could be great validation. And have you seen that happening, or how do these partnerships form?
Yeah. So for example, for Ascapus one, I was a brand ambassador for Eden Technologies, and they do basically ECG and EEG monitoring. And I just introduced them to Ascapus, and I was like, do you guys want to test these things on us doing the thing? We didn't do the measurement in the end because we had an ethical committee deadline that was not met. This is a big problem. Be aware of ethical deadlines is the worst thing. It's really annoying. But yeah, no, so the funding opportunities. So again, some missions really depends on the price. To give you an idea, a lot of them are about $1,000 to $2,000, for example. Okay, but you can reduce the price by half usually if you're a student or you can sponsor research. Look into university. If you're affiliated to university, look into that. If you're affiliated to a company, see if you could perhaps send it to somebody there and see how it is tested, etc. Again, every platform is different. Every mission is different. And also, for example, maybe you say, well, a mission of 4 days is not long enough. We need a mission that's 2 weeks long. Again, it's going to probably change your choice. But definitely medical tests are very interesting. I think it was Lucy Rakova, so she's from Czech Republic, and she was doing stress measurements, some physical stress. I thought not material stress, but physical stress on astronauts that they felt doing those analog missions, and they managed to test basically the program on that. So it's quite interesting to see that you can validate things during analog missions. Sometimes it's just about having the right contact or funding the mission that really suits your program. And if your university doesn't really listen to you, you can maybe look with SGAC, so Space Generation Advisory Council, if you're part of this, or I'll have a look at UNOSA, so United Outer Space Affairs, I think it is.
Yeah, Eleanor, Susan. Yeah, so it's the UN UNOSA, which I'm a mentor for that program. Where I'm actually mentoring several and it's for women for space. And so because Eleanor, yeah, those are great suggestions for people interested in joining missions, and always financial is a problem. So I've known this since I started this whole field, right, over a decade ago, believe. And so what we've done, and because our organization is pretty different from like MDRS and all these other lunaries, and is that we're a for-profit. So we do get funding, sponsorships from corporates, from private investors, and that allows us, right, because we're also there's a research arm to what we're doing, allows us to offer scholarships for qualified students or qualified professionals who want to retrain or reskill. And so there are many opportunities that definitely if you're part of a university, but not everybody that comes into these analogs they might be citizen scientists, and they want to have this experience, or they want to bring in a project because they have their own startup company. So there are many ways to navigate, and at the end of the day, it's what fits you. There are many different options, but for us, and I put it in the chat, is that we have offered scholarship and will continue offering scholarships for qualified individuals, and these upcoming missions that we have, including the underwater of the Florida Keys, is going to be sponsored by several big US companies to do research. And so we will be actually more akin to what NASA does for the HERA, the Human Exploration Research Analog, and the one that they built is that you're not paid volunteer, you're not a volunteer, so you don't pay for it. It's vice versa. You get paid to come in as a participant for crew. So it's a whole different role. That when you're paid, you're like an employee, so you have to do what they tell you. Of course, you have to sign waivers and liability, and you have to conform to their rules and protocols, versus coming in as a volunteer and you're paying for your slot. Then you have some degree of autonomy and decision of what, some degree, you can't, or you still have to follow the structure of the mission and so on and so forth. So you don't break sim and you don't, harm others in the crew. Safety is priority. So there are many different ways that you can participate and find funding or be offered, if you qualify, to be supported. And all of this is part of having the experience, and two, to actually, if you are in academic or you want to find employment later on, it's such a unique experience, right, Eleanor, and those who've been in Analogue, when to have it on your CV is actually puts you in 1% of the competitors when you're trying to apply for a job or you want to
Definitely.
try to go, to a degree program. So that's what, I want to
Yeah.
share with everyone.
Yeah, thank you so much, Susan. That was really good insight, especially with like the opportunities you put in the chat for other students to really look into and check out, and even email Susan or Eleanor if you're interested in these analog opportunities. I think there are so many cool experiments being done. I think I know Sue was asking about where can we learn about all of these experiments that are being done, and Eleanor pointed out that they're actually creating a database for all these experiments. But even if you go on like the High Seas website or just search up Analog Missions 2023, there are so many groups who are actually publishing all of the results that they're collecting from these experiments that they do on these analog missions that are so cool to read. These are real research papers that are published on the internet for anyone to read and access. And they do experiments both related to the physiological body changes, but also mentally what happens to astronauts on Earth through analog missions and what happens to them. And I think Eleanor pointed out, some really good things about analog missions that I don't want to get into because we're running out of time. But there is one more question that Martina asked that I'd love if you could answer, which is, would it be possible for you to elaborate on the ethical committee deadline? Does every mission have that?
So the ethical committee is an issue when you have tests that have been conducted on the astronauts themselves. So psychology or, for example, physiological. So for example, if you need blood samples, urine samples, or even stuff where, you answer a questionnaire, depending on the country where you come from, depending on the institute that this experiment is affiliated to, you need to fill an ethical committee form. And in Switzerland, typically we have different ethical committees depending on where we are in Switzerland, plus there's the one of the university itself. So even if you get one, if you don't get the other, then you have a problem. And it's dumb because it's a very tiny administrative thing, but it's actually there to protect the astronauts. And for example, the first base we were supposed to be in the Sky Guide habitat. And to feel isolated, we were supposed to cover the windows. That was before we decided to get the base underground because of COVID. And when we were picking that habitat, they said, you're not allowed to cover the windows because it's like an infringement on behalf of the astronauts. And it was really dumb because you're like, so it's okay for us to be 450 meters on the ground, but covering the windows of the habitat that's outside is a no-go. So be really wary of this. The best is when you send your experiment, for example, for review, because a lot of those habitats, they select those experiments. Okay, they will tell you this is okay, this is not okay. Ask them, what are your ethical committees in the country or affiliated with the mission? And then they will know, basically. So that's the main thing, is really just check that. A little thing that Gitika mentioned before about the publications, yes, do check. There's lots of publications coming out. It's really exciting, really cool. And especially we get them at the Astronautical Congress. That's where there's a lot of presentations of these missions. But we're trying to get a yearly edition with the British Interplanetary Society of Analog Space Mission Research only. So we normally get once per year a journal. So it's not the space flight, it's the space journal from BIS that's going to be just on analog space mission research. And maybe, who knows, we're going to have to do it twice a year or 3 times a year with every year because there's going to be more and more research. But yeah, I'm sorry that we talked so much. I hope it was very interesting for all of you and that you all take part in analog missions because they're absolutely fantastic and just such good learning and teaching opportunities, really.
Yeah, thank you so much, Eleanor, for this, conversation. I learned so much. And I put in the chat a link to a community that all of you can join. I know as a young student, even myself, I'm looking for ways to get my first analog mission. And it's so difficult when I don't have a degree yet or the technical skills to be able to do an analog mission. But there's this incredible community that anybody can join, attend the Analogue astronaut conference that they have every year on a scholarship. If you get the scholarship, you can also interact with current Analogue astronauts, and they post whenever a new Analogue mission is open for applications, even if you're not necessarily qualified. It's all knowledge and information, and I think that's the first step to becoming an Analogue astronaut, to then setting you up to do all of these really cool experiments. So if you don't know already about this community, I would definitely join it. Dr. Cyan Proctor actually is one of the co-organizers of this community, so it's a really cool place to just learn about Analogue missions. So I want to thank you so much, Eleonore, for doing this today. I learned so much. I'm sure everyone has so many questions to ask you, so I'm very excited, and hopefully we'll come across each other at an Analogue mission in the future.
That'd be lovely. Thank you so much for hosting, and I hope you all enjoyed the rest of the event. That is so far really, really cool. So well done, and thanks also Mark for inviting me. Really, it was really nice to be here.
Thank you.